Hi everyone. Today we're going to learn about graph of parent sine and cosine function, and also we'll learn about transformation of those two functions. So we're going to start with graphing sine and cosine, but we need some points. How do I make the points? I made this table for you that has some of the angles from 0 to 720, and also on these tables we have the value of sine and cosine of those angles. If you wonder where did I get these values, I can explain it for you here. If you have the unit circle, you know that you have some points on the unit circle. These points have coordinates. The x value of its coordinate represents the cosine, and the y value of the coordinate represents the sine. So if I ask you what is sine of 90, you're going to look at the angle 90. The y coordinate is sine of 90, it's 1, and x coordinate is cosine of 90. So that's how we can find all these values that you have on this table. However, you know that on the unit circle, you can see 0 to 360, but you cannot see 450. But we know that 450 is basically 360, which is one full circle plus 90. So in order to find sine and cosine of 450, you just need to look at 90 and take these two values. Or 540 is 360 plus 180, so you need to look at 180. 630 is 360 plus 270, and 720 is 360 plus 360. So you can just find all those values on the unit circle and find the x and y coordinate. Now that we have all those points, we're going to graph them. Here on this coordinate plane, the x-axis represents the theta, the angles that you see here. So I have labeled them all here. And the y-axis represents the value of sine. The values, as you see here, they're all 0, 1, or -1. These are the values that you have here. So the highest value is 1 here, and the lowest value is -1. And the 0 is already here in between them. Notice that there is a pattern here. 0, 1, 0, -1, 0, 1, 0, -1. And even here for cosine, 1, 0, -1, 0, 1, 0, -1, 0, and so on. Okay, so let's see how does the graph look like if I graph these points first. So the first point, 0 and 0, that's here. Second point, 90 and 1, that's here. 180 and 0 is the next point. 270 and -1, you see that's this value. 360 and 0. 450 and 1. 540 and 0. 630 and -1. And 720 and 0. So now I'm going to connect these points, but notice that you have to connect them with a curve, not a straight line. Because if you find some values, some other values, we found only a few angles, but if you find more and find some more points, you will see that they're going to look like a curve when you connect them to each other. It's not a straight line. So I'm going to create my curve right now. Okay, so this is the curve that you see here. I just connected all the points together with a curve. Now, as you see, this function is repeating itself. There is one cycle here. This is one round of the function. And then the second one is just repeating the first part. So we call this function a periodic function. It's a function or graph that repeats itself. So that's why we call this periodic function. Now I'm going to graph cosine. Again, I'm going to look for those points, 0 and 1. The first one, so let's say 1 is here, the highest point, and -1 is here, the lowest point. So the first point is at 0 and 1. So that's here. Next point, 90 and 0 here. Then we have 180 and -1. 270 and 0, 360 and 1, 450 and 0, 540 and -1, 630 and 0, 720 and 1. So now I'm going to connect these points together using a curve again. So I'm going to connect them this way. Again, make sure you use a curve. So if you notice, again, we have a periodic function because it's repeating itself. One cycle is this from here to this point, and the other cycle is this one. So it's repeating itself. So notice that there was a pattern here, and I see that pattern here as well, but in this way. The graph of sine is from a middle point here, then goes to a high point, middle point, low point, middle, high, middle, low, middle. And now here I have high, middle, low, middle, high, middle, low, middle, high. So there is a repeating pattern here. So these two graphs are graphs of sine and cosine. And now we're going to look at this table and fill out the table for these functions. So we want to know what is the domain and range of these two functions, sine and cosine. Notice that what you see here is just part of the graph. It's not the whole graph of sine and cosine, because on the unit circle, we don't have only 360 degrees. We don't even have only 720 degrees. We have infinite number of degrees on the unit circle. That depends on how many circles you want to create it, like how many rounds you want to go around the circle. So this is 1, 2, 3, and you can make infinite number of rounds here. So they're going to create infinite number of angles. You could either go to the negative direction and make negative angles, infinite times make circles around here, and then you're going to have infinite negative angles. So that means this function doesn't end at 720 or at 0. It's going to continue from left side and the right side. So you're going to have the rest of the function here and also here, but we don't have enough space to graph all these functions. So that's why we graphed only part of the function. And the same is for cosine. It could continue moving forward or backward the other direction. But again, we don't want to graph the whole function because we don't have a space for them. But we know that the angles that we have are infinite number of angles. So sine and cosine are going to repeat themselves for infinite number of times. So that's why here, if I want to write the domain of the function, I say this is the domain is from negative infinity to positive infinity, because it's covering infinite number of values, negative infinity to positive infinity. The domain for the cosine is also the same, negative infinity to positive infinity. What is the range? For range, you know that you're looking for the y values from the bottom to top. And you see that the lowest value is -1, highest is 1. And the same is here, lowest is -1, the highest value is 1. So the range of the function is from -1 to 1. And we're going to put that in bracket because the -1 and 1 are included. They're part of the function. There's no whole or open circle here. So -1 to 1. Next part of the table is asking us about the start point. What is the start point? That's where your function is starting in one cycle of the parent function. So this first cycle that you see here, I'm going to highlight. This is the parent sine function. Or this one is the parent cosine function. So where does it start from? Sine starts from 0 and 0, but cosine starts from 0 and 1. This is the main difference between these two functions, 0 and 0, 0 and 1. That's the start point of these two functions. That's basically the only way that you can find if the function is sine or cosine, because they really look like each other. They have the same pattern. The only difference between them is where they start from. So if you're given a function that starts from 0 and 0, you know that it's sine. If it starts from 0 and 1, that means a high point, that's a cosine function. Maximum and minimum value for both of these functions are 1 and -1. So here max is 1, minimum is -1. Now, let's see what is amplitude. Amplitude is given here. It's the distance from the sinusoidal axis to the highest or lowest point. So what is sinusoidal axis? That's the horizontal middle of the graph. So what is that? Horizontal middle of the graph is this line. You see, the horizontal line that is passing from the middle of the function. And here is at y equal to 0. And also here, the horizontal middle is this one. So these two basically are the sinusoidal axis of these two functions. Now, what is the amplitude? We said it's the distance from the sinusoidal axis to the highest or lowest point. So this distance is the amplitude. For short, I'm going to write AMP. Or this distance, they're both the same amplitude. And even here, for the cosine, distance between highest and the sinusoidal axis. That's the amplitude, or the lowest. Notice that when we're talking about amplitude, it's just distance. So we're talking about distance, not the direction. That means this amplitude is always positive. Even if you look at this value, which is below the x-axis, it's always positive because it's just a distance between them. And for the parent function, amplitude is 1. The distance between highest and the sinusoidal axis is 1 for both functions. This is also 1. So the amplitude is 1. Next, we're going to talk about the period of the function. What is period? Period is number of degrees or radians for the graph to complete one cycle. So what is a cycle? A section of periodic graph before it repeats. So let's see. This function that you see, a section that it doesn't, before it repeats itself, that's the part that I already highlighted for you. This is one cycle of the graph. So how many degrees does this function need to complete one cycle? As you see, it's from 0, 362, 360. So the period of the function is 360 degrees. That means it needs 360 degrees to complete one cycle. To complete the other cycle, the second cycle, again, it needs 360 degrees. And the same is for cosine. So the starting point is here, and the end of the one cycle is here as at 360. So again, period of this function is 360 degrees. If you want to find the period of any function, all you need to do is find the distance between 2 points, 2 repeating points, like this distance. These are the 2 high points. They're repeating each other. So that's the period of the function. Or you could consider distance between 2 low points. That's also giving you the period of the function. You could also find the distance between 2 middle points. That's this one. Notice that these two are repeating each other, but this one and this one are not repeating because after the first point, the function is going up, but after this point, the function is going down. So they're basically not repeating each other, although they're both at y value of 0, but they're not repeating. But this point and this point, right after them, the function is going up, so they are repeating. So anyway, we said that in order to find the period of the function, just find the distance between 2 repeating points. Again, here, 2 high points, 2 low points, or two middle points. And the period was 360 degrees. And here as well, these are the period of the function. But if the function is in degrees, it's 360. If the function is radian, or if we're using the radian measurement of the angle, then we say the period of the function will be 2 pi, because you know that 360 is 2 pi radian. Okay. Sinusoidal axis, we already talked about that. It's y equal to 0 for both functions. Notice that the sinusoidal axis is a line, is a horizontal line. So you need to write that as a y equal. You cannot just write 0. It should be y equal to. Now we're going to talk about critical points. What are the critical points of the function? Critical points are the points that important changes are happening. Like, for example, this is a critical point. It's the maximum point of your function. Before the point, the function was going up. After that, it's going down. So this is a critical point. An important change is happening. Or here, before this point, the curve was a downward curve, but right after that, it's an upward curve. Or this one is the minimum point. The function was going down, after that is going up. So all these points are critical points. I'm going to highlight all of those, like 1, 2, 3, 4, 5 critical points on one cycle. Or here as well, 1, 2, 3, 4, 5 critical points for the cosine. Those are also the points that critical changes are happening. So how many critical points we have on each period? We have 5 of them. And as you see, those critical points are dividing the period into 4 equal pieces. You see 1, 2, 3, 4 equal pieces. So how do I find the critical points of a function? By dividing the period of the function by 4. This is going to give you the steps between the critical points. So this is going to be steps between critical points. Divide the period by 4, and it's going to give you the steps between them. Now, starting the first point, you just add that step. So like in this example, period is 360. 360 divided by 4 is 90. So the steps are 90. So you're moving by steps of 90 to get each critical point, from 0 plus 90 plus 90 plus 90 plus 90. So that's how you find the critical points. So the critical points of the function are these values: 0, 90, 180, 270, and 360. And the same for cosine. If you're asked to write the critical points in radian, you just need to change all these values to radian. For example, here, the radian measure of all these angles are 0, 90 is pi over 2, 180 is pi, 270 is 3 pi over 2, and 360 is 2 pi. And the same is for the other function for cosine. So the critical points are just the same points, except that they are written in radian. Okay. So we learned all the basics about the parent sine and cosine, and now we're going to learn about transformations. So this is the general form of the sinusoidal, for any sinusoidal function or any trig function, with the transformations that could happen to them. So let's see. Here, if you see this word trig, that means just any of the trig functions, like sine, cosine, or tangent, or even cotangent. So what transformations could happen? If the function is multiplied by a value, let's call that a, then vertical stretch or compression is going to happen. So If the a value is greater than 1, you will have a stretch. If the a value is less than 1, you're going to have compression. Since you're stretching your function vertically, that's going to change the amplitude of the function. So for example, here, this is the parent sine function. If I have y equal to 2 times sine of theta, that means we're stretching function by factor of 2. So the amplitude, which was 1, now it's going to be 2. It's going to be here. This is going to be the highest point. And the lowest point, which was -1, since the amplitude was 1, now it's 2, it's going to go here. So the graph of the function will be vertically stretched, and it's going to look like this. I'm going to graph it one more time. Okay, this looks better. So notice that the middle points, which were at 0, are going to stay the same place that they were, but the highest and lowest points will be stretched by factor of 2. But if the a value that you have is negative, like for example, y equal to -2 times sine of theta, then the amplitude will be still the same, but there will be a reflection over x-axis as well. That means this high point will be reflected and it's going to be a low point now. The low point will be reflected and it's going to be a high point. So now the graph is going to be stretched and by factor of 2, and also it will be reflected over the x-axis. So the negative is just reflecting your function. It's not going to change the value of the amplitude. So the amplitude is still 2 here. Okay, the next thing that could happen to your function is when you multiply the theta by a value. So that's basically something that is happening to the x. So that's going to be horizontal stretch or compression. We know that anything that happens to your function and is inside, it's happening to the x value, it's going to act opposite. That means if the value is less than 1, you're going to have a stretch. If the value is greater than 1, you will have compression. It's going to horizontally stretch or compress. So this function will be horizontally stretch or compress. It's going to change the period of the function. So how does the period change? We know that the parent sine or cosine function, they have a period of 360 or 2 pi. But the new period will be this value divided by b, the number that is multiplied here, or here divided by b. So let's give you an example. Y equal to cosine of 2 times theta. So the period of the parent function was 360. If I divide it by this b value, which is 2, it's going to be 180 degrees. So the period is going to be shorter. Although this value is greater than 1, the period is smaller. Here, because our angles are measured in radian, so the period of the function in this case will be 2 pi divided by 2, which is pi. So the function is going to complete one cycle in pi radian instead of 2 pi radian. So it's going to look something like this. Let me graph it again here. So you see one cycle, which is the distance between two high points, is happening faster in pi radian instead of 2 pi radian. Okay. Next thing that could happen to your function is horizontal shift. That's when you add or subtract the value to your theta. It's going to move your function left or right. We call that also phase shift. Determines the start point. And as a result, the critical points will also change. Directions are always opposite the sign. Opposite the sign. because we know that inside the function, if you have minus something, it's going to move to the right. It's always acting opposite. If you have plus, it's going to move it to the left. So let's say I have y equal to sine of theta plus pi over 2. This is going to move the function right pi over 2. So the first point, instead of starting at this point, is going to start at pi over 2. All the points are going to be moved pi over 2 to the right. So this one will move here, this one will move here, this one will move here, and this one here. So the function will look like this. As you see, it's just shifted to the right, 1 point to the right. So this point is here. So that's how it looks like. So that's horizontal shift. And then vertical shift determines the sinusoidal axis. That means the horizontal midline of the function. And the direction is always the same as sine. That means, like here, you see, this d value. This is what is added to your function as outside of the function. This value is going to move your function up or down. It's going to change the sinusoidal axis. So let's say I have y equal to cosine of theta plus 2. Or I can even write y equal to 2 plus cosine of theta. They're both the same. So they will move the function 2 units up. So this function has a sinusoidal axis at 0, but now it's going to be moved here at 2. If it's moved to 2 up, it's going to be 1, 2 up. Now, every other point is also going to be moved 2 up. So the function will look like this. This point, which is 1 higher than the sinusoidal axis, is going to be here. So from the sinusoidal axis, I go 1 up, and then I have the middle point that's going to be on the sinusoidal axis. The low point is 1 down from the sinusoidal. So here, this is going to be on the sinusoidal axis. Then I have high point, and then all the other points. So this is my function. So it's moved up for 2 units. Okay, this was the first part of the lesson. I made one video for this one. I'm going to make a second part of the video over this part, and we're going to practice how to graph all these functions. So I'll come back with the second part of the video in very soon.